I am Tangashakti from AAA Department, Rohini College of Engineering and Technology. In this lecture, we are going to discuss about FIR design with windowing technique. So here we should know what is meant by window. So the windows are the finite duration sequences used to modify the impulse response of the FIR filter to reduce the ripples. So our aim is to reduce the ripples in the pass band and stop band. So we are going to modify the impulse response of the FIR filter with window sequence. So here we have different types of windows. The first one, rectangular window, Bartlett or triangular window, Hanning window, Hamming window, Blackman window and Kaiser window. So the rectangular window sequence is represented by the function WR of n. So here R represents rectangular window. So it's having the magnitude as 1 for this sequence. For the values of n varies from minus n, capital N minus 1 divided by 2 to plus n minus 1 by 2. And for another value of n, the magnitude will be 0. Second one, triangular window. So for the triangular window, the sequence will be the magnitude 1 minus 2n by capital N minus 1. For the values of n varies from minus capital N minus 1 by 2 to 2 plus n minus 1 by 2. For other values of n, the magnitude will be 0. Next one, Hanning window. So the Hanning window is also one of the type of cosine window. So it will be represented by WC of n 0.5 plus 0.5 cos 2 pi n by capital N minus 1. For the values of n varies from minus n minus 1 by 2 to plus n minus 1 by 2. For other values of n, the magnitude will be 0. Next one, Hamming window. So it will be represented by WH of n 0.54 plus 0.46 cos 2 pi n by capital N minus 1. For the values of n varies from minus capital N minus 1 by 2 to plus n minus 1 by 2. For other values of n, the magnitude will be 0. Next one, Blackman window. So the Blackman window is also one of the type of cosine window. So it will be represented by WB of n. So the magnitude will be 0.42 plus 0.5 cos 2 pi n by capital N minus 1 plus 0.08 cos 2 pi n by n minus 1. For the values of n varies from minus capital N minus 1 by 2 to plus n minus 1 by 2. N minus 1 by 2. For other values of n, the magnitude will be 0. Finally, Kaiser window. So it will be represented by WK of n I non beta 1 by I suffix non of a. For the magnitude, for the values of n varies from minus capital N minus 1 by 2, n minus 1 by 2. For other values of n, the magnitude will be 0. So next we are going to see about FIR filter design. So first one, we have to specify the specifications of the digital FIR filter. So first we have to calculate the desired frequency response. So that will be HD of e power j omega. So this is the desired frequency response. So here it will be represented by C into e power minus j omega, alpha omega. So here C is the constant and alpha represented by n minus 1 by 2. So next the cutoff frequency omega C for low pass and high pass, and omega C1 and omega C2 for band pass and band stop filter. Number of samples of the impulse response will be n. So next one, determine the desired impulse response. So for calculating the impulse response, the impulse response is calculated from the desired frequency response by applying inverse Fourier transform. So hd of n equal to 1 by 2 pi integral minus pi by 2 pi hd of e power j omega n into d omega. Next we have to choose the desired any one window sequence omega of n. So this window sequence omega of n is multiplied with desired impulse response to give the impulse response of the filter. So next calculate the n samples of the impulse response for n equal to 0 to n minus 1. So here we can understand impulse response can be obtained by multiplying the desired impulse response with frequency in the window function hd of n into omega of w of n for the values of n equal to 0 to n minus 1. So the impulse response is symmetric with the center of the frequency at n minus 1 by 2. So next we have to take the Z transform of the impulse response. So we will get h of z. So the h of z equal to Z transform of impulse response h of n. So sigma n equal to 0 to n minus 1 h of n into z power minus 1. So this is nothing but the standard Z transform formula. So next for the h of z we have to draw the suitable structure for the realization of FER filter. Thank you.